In this example, you're supposed to find equation of plane, right? Of the form r dot n equal to d. And there are three parts. The first part is perpendicular to the vector 4i plus 3j plus 5k and contains the point 2 minus 2, 0. So in part 1, the norm vector is given already. The norm vector is 4, 3, 5. So equation of the plane is just r dot 4, 3, 5 equal to, remember equation of plane is r dot n equal to a dot n. So r dot 4, 3, 5 equal to a. A is a given point, so it's 2 minus 2, 0 dot 4, 3, 5. So just look at the dot product. 2 times 4 is 8, then minus 6, then plus 0, so it's 2. So then it's the equation of the plane which is perpendicular to the vector 4i, 3j, 5k and contains a point 2 minus 2, 0 is just r dot 4, 3, 5 equal to 2. Let's look at part 2. Part 2 is supposed to find equation of plane passes through A, B, and C. And we shall make use of what I mentioned in the previous video. To find a norm vector, you'll find two vectors u and v which are parallel to the plane and not parallel to each other. And to do that is very easy. You can just find vector AB. Vector AB is definitely parallel to the plane, because the plane will contain the point A, B, and C. So if you can find AB, definitely is parallel to the plane. So AB is OB minus OA. So it's 2, 2 minus 1 minus OA is 1, 2, 3. And you'll get 1, 0 minus 4. Next you can find vector AC. So it's OC minus OA. So this will give you minus 1, minus 2, minus 2. So we can take this as vector U, this as vector V. So we consider U cross V, which is I, J, K, and then 1, 0, minus 4, minus 1, minus 2, minus 2. So you work out this dot product, you give you minus 8, 6, minus 2. And what you can do is, you can actually take out a common factor. So you can take out a common factor 2. Then it will give you minus 4, 3, minus 1. So you can make it smaller by taking out common factor. So you will get minus 4, 3, minus 1 as your normal vector. So that means you can take a normal vector as minus 4, 3, minus 1. So we have found a normal vector to the plane, right, containing ABC is minus 4, 3, minus 1. And after that, we need to find equation of the plane, which is r dot n equal to a dot n. A is any point on the plane. So we can say equation of the plane is r dot minus 4, 3, minus 1 equal to a dot n, right? Is r dot n equal to a dot n. A is any point on the plane, so you can choose 1, 2, 3. So use 1, 2, 3 dot with minus 4, 3, minus 1. You can work this out, it will be minus 4 plus 6 minus 3. It will give you minus 1. You can try with other points. You can consider r dot minus 4, 3, minus 1. Instead of taking A, you can take B, which is 2, 2, minus 1. And dot with minus 4, 3, minus 1. Then you will find that it gives you minus 8, plus 6 and plus 1. So it also gives you minus 1. You can try out with the point C, which is minus 4, 3, minus 1. End up with, so it's 0, 0, 1, 0, 0, 1, dot with minus 4, 3, minus 1. Then you'll find that this is the easiest point to use because there are two 0 terms. So that means the point 0, 0, 1 dot with minus 4, 3, minus 1 will just give you minus 1 because you just take the last component, which is non-zero, which is 1 times minus 1 give you minus 1. So that means for part 2, right, to find equation of plane containing the point A, B, C, containing A, B, C. After you find the number, after you have found the null vector, which is minus 4, 3, minus 1, then it doesn't matter which point you take. You can take point A, point B, point C, and take it as A, and you look out A dot N. It always give you minus 1. So the answer you need to give is just R dot minus 4, 3, minus 1 equal to negative 1.